can't divide by p, obviously that's valid, but one thing you can also do is distribute. So if you take a look here, I can distribute, I'm solving for t, now I subtract p, and now I can divide it by PR, and then this, then we're good. Okay, then we're good as well. All right, what other issues are those later ones? Do we need to look at? We can't look at them all, but we can look at one or maybe two. Yeah, sorry.
Can we go over 79?
79, anything before that?
55.
55, all right, we'll take a look at 55 and 79. And other than that, come see me. So 55, where's our problem?
A equals quantity A plus B times H.
A equals, what'd you say?
A plus B.
Quantity H?
Yeah.
What are we solving for?
H.
Solving for H? What'd you do first, Aubrey?
Multiply both sides by 2.
Oh, was there a 2 in front? Was it 2 times A plus B?
It's over 2.
Oh, over 2. So you multiply both sides by 2. This is not working. There we go. And that gives us 2A, right? Equals A plus B times H. All right, now what are you thinking?
Well, don't you have to do the right side by 2 also?
All right, when you multiply it by 2, here's what happens. That cancels. Okay. So the 2 cancels. So anytime you multiply it, what that does is that those 2 values cancel. You don't actually end up multiplying by theoretically. The 2 doesn't get multiplied. So once you have that, now you can divide by that quantity A plus B. You wouldn't need to distribute here because we're solving for the H. We are solving for the H. 2A over A plus B equals H. Now, I do make some comments on your homeworks at times. Sometimes I put a comment in the section. Sometimes I'll actually write on it. I don't know if you ever go back and look at it again once you submit it. Okay, but if you do, there will be comments on it at times. All right, 79. That is a hard one, but not too hard for this class. Not too hard. So 79. A times A plus X. Equals
B squared minus BX.
B squared minus BX. Solve for X. And then, but what does X equal? BM minus A? Is that right? Is that correct?
B minus A.
B minus A. Now, that's what you should, I believe that's in the back of the book. You should be looking that up so you know what, whether you're right or once you're at one point. Now, a lot of you are correct, but you didn't finish. Like you couldn't get to that point. For that one. All right, what can we do? What can we do? Nathan Moore.
You can distribute the A out to the A plus X.
Okay, and that gives me A squared plus AX equals B squared minus BX. All right, take a look at that. We're solving for X. Adam Lippy, what can I do now?
Well, I misread it and I solved for A.
Solve for A. All right, well, we're back on solving for X. So what did we learn?
You gotta get your X's on the same side.
All right, and that's what I was looking for. If you're solving for X, any term with an X on the same side, everything else on the other. So I think I'm counting on everybody to be able to do that. And that depends on whether you move to the right or to the left. I would probably add BX because I try to make that as the terms with the X both positive I can. A squared plus AX plus BX equals B squared. Now I gotta move the A squared over, so I'm gonna subtract it. I'm just gonna do that here. AX plus BX equals B squared minus A squared. All right, so from right there. Cole, what do we do now? What do you think?
So then I factored out the X from my AX plus BX.
That's what I want to hear. Factor out the X. So if you're looking at it's in 2 terms, we're going to factor that out. Okay?
And then the b squared minus a squared is a difference of squares. So I did b minus a times b plus a.
All right, you're way ahead of the game. Excellent. I'm going to divide by a plus b first because that's what a lot of people did. So a lot of you did this, where this is what I typically see. I get x equals b squared minus a squared over a plus b. And so technically you're solved for x, okay? You've got the x by itself. You haven't made any mathematical errors, but that's not what's listed. So like if you get a multiple choice test and then you don't see that, you're like, oh crap, what did I do wrong? Well, you're okay, but now how do I get this to be the answer? Well, Cole told us he noticed that b squared minus a squared is a difference of squares. And then what happens there is you get a plus b, and the b plus a, they're the same. Those cancel. And so that's how we get b minus a. So we're done.
Could you also just simplify the exponents and subtract from the top and the bottom?
No. And I don't know if I can explain the best way to explain it. So just say, hey, there's a b there and there's a b there.
Yeah, I did that too.
And there's an A there, and there's an A there. Cancel it. Doesn't work that way. Okay, so one thing you got to watch, and some of you did this. Let's see. What do I want to do? Can I cancel those B's? Can you cancel those B's? Half of you saying yes, some say no, absolutely not. Cannot cancel those. Okay, now let me see if I can explain why. If I cancel them, what are you going to tell me the answer is? What is it?
A over 2.
What happened to that? Okay, so a over 2, some of you might say it's 1 plus a over 2. Okay, but they're not equivalent. So they have to be equivalent. So if I substitute in numbers for b and a, so if b is 6 and a is 2, everything has to be the same. What is 6 plus 2? That is 8. What's 2 times 6? That is 12. So that's 8/12. But what's a over 2 the same as? That'd be 1. They're not the same. They're not equivalent. Even if you say this is 1 plus a over 2. Here's your rule. To cancel something, it has to be part of a multiplication problem. To cancel anything, it has to be part of a multiplication. That's why we factor everything. So here's when you can cancel. If you have b times 2 plus a over 3b, can I cancel these b's? Yes. If I have over 3a, can I cancel these a's? No, because that is not part of a multiplication problem. So you cannot cancel. Now, in your mind, it might have worked out right. That's luck. Okay, so you can't say, I'm going to cancel that b and that b, that a and that a. Okay, so every now and then that situation will arise, but it's luck. Okay, cannot cancel here. Okay, it has to be multiplication, connected by dots, we say, in order to be able to cancel. And that's the same thing with a whole quantity. If I want to cancel that 2 plus a, if I have 5 times 2 plus a, then I can cancel the whole thing. Okay, that's fine. All right, that's the homework wise. I'll make some comments on it. Make sure you do your job. Make sure you do your job. Make sure you check it, and that way we can come through here. I need you to write just a couple things down, and then we're gonna do some more problems. Okay, we're gonna do some more problems. This is usually like everybody's favorite section. For some reason, I don't know why, everybody just loves to do word problems. Yeah, pick up my sarcasm. All right, now we can call them applied problems. It makes it sound better instead of word problems. And we're going to do linear equations for those. You don't need to get this whole mess. You just need to get that I equals PRT. Simple interest. Simple interest. I equals PRT. Now P stands for principal. Okay, that's the amount of money. So like if you got $2,000 in the bank at 2%, you multiply those two together, and that'll give you your interest for whatever amount of time. If it's for 1 year, or it's a half a year, or 2 years. Okay, that's how you do interest. Motion, physics, you'll deal with this a lot. And there's common sense, but I still want to write it down. Distance equals rate times time. V equals RT. All right, now this last one's really important because you're not as familiar with it. This is the mowing the yard problem. Okay, your mom and you are mowing the yard. 2 different people are doing something. How long does it take them to work together? There's different ways to figure it out. Like we figured it out by figuring out how much you did in an hour and working that way. But this is a pretty helpful formula. So T over A plus T over B equals 1. You might want to indicate what the T and the A and the B are. While you're doing that, the actual examples we're going to do together, I got on here so you don't have to just take the time to write them down. All right, let's take a look at that first one there. And the one, you can look at it 2 ways, a good thing or bad thing. I mean, these problems are all going to be a little different. It's not like you can just follow one, I guess, procedure and do it for all of them. You're going to have to think a little bit. Okay, you're going to have to think, you're going to have to reason, you're going to have to see if something makes sense and kind of move that way. All right, there are 32,000 people at a ball game in LA. The day's receipts were 200,000. Well, this obviously isn't this year because there's 0 people at a ball game and there's no receipts. How many people paid $12 for reserve seats and how many paid $4 for general admission? I'm going to let X equal reserved seats. Now, eventually you can get to the point where you do systems equations with this one. We're not going to do that. We're going to do a linear equation. That means I need to write the number of general admission seats in terms of X. Okay, we know they both have to add up to 32,000, right? There's 32,000 people. So the number of reserved seats plus the number of general admission has to equal 32,000. We'll isolate the G. What does G have to equal? Okay, just do what with the X? Subtract it. So the number of general admission seats has to equal 32,000 minus X. And so we're going to use that to represent the general admission. So that way everything's in terms of the same variable. I don't have to introduce a second variable. So 32,000 minus X equals general admission seats. All right, now the money's going to come into play. So you pay $12 for every reserve seat, and you pay $4 for every general admission seat, and we get a total of $200,000, right? So 12 times the number of reserve seats plus 4 times the number of general admission seats equals 200,000. But I'm not going to use G for general admission. What I'm going to put in that spot, I'm going to put in 32,000 minus X, okay, because they have to add up to 32,000. So that's going to be my equation is 12X plus 4 times 32,000 minus X equals 200,000. That's the issue with word problems. You've got to get the equation. If you get the equation wrong, then everything else is going to be wrong after that. You have to be able to analyze your answer to see if it makes sense. So go ahead and multiply by 4. Go ahead and solve for X. See what you come up with. I'll do it here in a second. Tony, you get X yet back there?
No.
Not yet, still working?
Not yet.
All right, let me know what you get. Just shout it out.
I got X equals 9,000.
9,000, very good. So as should everybody else. So X equals 9,000. If you didn't, I'm going through the work here, double check yours. Probably just say minor error. And I get 8X equals, what is that, 72,000? And then X equals 9,000. So X is 9,000 reserve seats. And then was that, so how many general admission? So 32,000 minus 9,000 gives us 23,000. Okay, good. 23,000. 1, 2, 3 general admission. Okay, good. Common trick here, when you have two things that add up to like 32,000, you let one be X, you let one be 32,000 minus X. Okay, so that's how you can split it up and still use one variable. All right, read through this second one. Read through this second one. And this deals with that interest problem. Now, since time is 1 year, the annual income is kind of implied. It's not specifically said, but this is, you're calculating interest to find the income from the investments. So you take principal, which is the amount, times the rate, times time. Well, time is 1 year, so basically we just need the principal times the rate. So the amount of interest from one investment, so I'm just going to call it I1, plus the amount of interest from the other investment has to equal 5,500. That's what's happening there. The amount of interest plus one plus the amount of interest from the other. All right, how do I calculate the interest? It's amount times the percent. Well, we know the total is 70,000. Do we know the amount for each one? No, so let one of them be X. So the amount at 7% invested is going to equal X. If I do that, how can I represent the amount of 10%? 70,000 minus X. So there's that case. They add up to 70,000. One of them's X. The other one's 70,000 minus X. All right, you know how to set up the equation? Okay, Emily? You know how to set it up? Yes, no, maybe?
Maybe.
What do you
I
got?
don't know.
What can we do? So what would be the interest for the 7%?
70,000 equal.
What would be the interest for the amount at 7%? We gotta take the interest rate times the amount. And what are we letting equal the amount?
X.
X. So the interest rate is 7%. Make that a decimal. So I'm gonna make it 0.07 times X plus. All right, Emily, what would be the amount of interest at 10%?
0.1 times 70,000 minus X.
0.1 times 70,000 minus X. Excellent. And that has to equal 5,500. Okay, that is a correct equation. And now it's just solving it correctly. Okay? Distribute. We'll combine like terms. I'm going to go through it up here as well and talk you through it. But when you distribute the 0.1 times 70,000, 10% of that is 7,000. Minus 0.1x equals 5,500. All right, now just be careful here. 0.07 minus 0.1. 0.07 minus 0.1 is negative 0.03. Sometimes you just look at it and you just say 0.3. It's 0.03. Negative 0.03x. I'm going to subtract 7,000. And when I do that, what do I get? I get negative 1,500. Now we get dealing with money, so you got to come up with a positive answer. So you screw up with negatives in one spot, then you get a negative answer. That just indicates that can't make sense. All right, what's 1,500 divided by 0.03? Caleb Mazaka, you got it?
Not yet.
What?
I was writing it down.
I'll wait patiently. 50,000. All right, good. So 50,000. So what do they want to know? Make sure you answer the question, because sometimes you go to what you solve for doesn't necessarily answer the question directly. You might need to manipulate a few things. But the amount invested at 7%, it is 50,000. So 7% is 50,000. And even though it doesn't ask for it, that means what's the amount at 10%? That would be 20,000. Okay, so there you go. Use that common thing in those first two problems. One is X, the other is the amount minus X for that one. All right, take a look at that third one. These problems sometimes are really, really easy, or they're very hard, okay? And sometimes you can kind of intuitively figure it out without using an equation. And I understand that work. It's probably especially distance, rate, and time. Or other times you kind of have to have an equation. Two boats are driven in opposite directions. One's at 6 miles per hour, the other at 12 miles per hour. In how many hours will they be 54 miles apart? Which means that's the total distance. And I want to say they're leaving from right there. One's going one direction, and then one's going the other direction. Distance. Are the distances going to be the same? No. Are the times the same? Are they traveling the same amount of time? Yeah, they leave at the same time. And how many hours are they 54 miles apart? So a lot of times what I'll do is I'll say d sub 1 has to equal rate times time. In the second distance, this is a different distance, call it d2. And what do those two distances have to add up to? 54. Well, the first distance is, what's the rate? The rate is 12. The second one is not going as fast. It is 6. So you get 12T plus 6T. And now I'm going to put those in here. Equals 54. 18T equals 54 divided by 18. T equals 3. 3 hours. Just thinking through that, when a lot of you would probably come up with that just intuitively. Like, oh, 12 and 6 is 18. It'll take 3 hours to be 54 miles apart. Sometimes it might not be that easy. Okay. All right, flip it over. Frank can type a report in 2 hours. James takes 4 hours to type it together. How long will it take the two of them typing it together? No, we're not going to add those together, divide by 2 and get 3. Okay. And you have to be able to identify what the type of problem is. When you're talking about 2 people or 2 machines or whatever versus individual time versus total time, it's that formula we wrote down earlier. What was that formula we wrote down? That is the T over A plus T over B equals 1. T over A plus T over B equals 1. Total time is T. A is the time for one, B is the time for the other. All right, so what would I do to set that up? T over 2 plus T over 4. The 2 is the time for the first person. Who's that, Frank? And the second person is 4 hours. Now you got the equation. The question is, we got to be able to solve it. Okay, we got to be able to solve it. Get rid of the fractions. What can you multiply by to get rid of the fractions? That's probably, I think that's the easiest. What will 2 and 4 both go into? 4. Multiply everything by 4. Now, when I do that, what does that actually give me? Take a look at it, and we'll make sure we understand this. And you got to multiply all 3 terms by 4. Jacob, what do you get? What's 4 times T over 2?
2T.
2T, good. The 2 and the 4, the 2 cancels into the 4, gives you 2. So I get 2T. Madison, let's see, what do you think? What is T, 4 times T over 4 give us? T, because the 4's cancel. All right, and I give you the hard one. Lane.
4.
Yes, 1 times 4 is 4. Got it. 2T plus T is 3T. 3T equals 4. Divide by 3. T equals 4/3. If you leave it as 4/3 of an hour, what would that be in hours and minutes?
1 hour, 20 minutes.
1 hour, 20 minutes. Okay, 1 hour, 20 minutes. So if you want to know that, 1 hour, 20 minutes. Okay, good. 1 hour, 20 minutes. All right, now the last one, we got to do a little bit of background before we get to this one. Look at this up here and see if you can understand what's happening. 10 liters of 50% OJ plus 20 liters of 20% OJ is going to be 30 liters of what percent? Don't just add them up and divide by 2. That doesn't work. You got to think through it. So when you have like a percentage, it's like how much pure orange juice you have. So like 50% of it's pure orange juice, the rest is water or whatever. That's 20% pure orange juice. The rest is water. If you just pour those together, this is chemistry now. What do we end up with? What percent? Or how do I figure it out? Okay, how do I figure that out? Figure out how much pure orange juice you have in each one. So if I got 10 liters of 50%, how much pure OJ do I have? Okay, I'm going to make sure I'm making sense here. Mackenzie Ward, how much pure orange juice would I have?
5 liters?
5 liters, just 10 times 0.5. Yep, so pure OJ. I got 5 liters. Plus, okay, how much pure OJ do I have in the second one? Cole Rhodes.
4 liters.
4 liters. 20 times 0.2 is 4 liters. So when I pour these two together, how much pure orange juice do I have? 5 plus 4 is 9. What's the percent? 30. Okay, so you got 9 liters out of how much? 30. So 9 divided by 30 gives me 30%. So you kind of need to understand that. All right, so as you take a look at that example. All right, I got a big grid here. Don't worry about that yet. I'm going to do that second. I'm going to see if we can come up with an equation. Some of you will like that, some of you won't. How many liters of a 20% alcohol solution must be mixed with 30 liters of an 80% solution to get a 40% solution? So we got a 20 plus an 80, we need a 40%. Basically, you want to figure out how much pure alcohol is in each one. It's really percent times amount plus percent times amount of the two that are being added together, and then here's your mixture. That'll be the final percent times the amount. Well, what's the percent of the first one? It is 20%, 0.2. I'm going to come back to the amount. What's the percent of the second one? 80 plus 0.8 equals 0.4. The final mixture has to be between those two. You can't exceed the highest one, and you can't be lower than the lowest one. All right, how about the amount? How many liters of the 20% solution do we have? Josh? X. We don't know, do we? Don't know. Let's put an X in. Unknown. How many liters of the 80% do we have? 30. 30. Tells us 30, right? So therefore, how many liters of the final mixture do we have? 30 plus X. Now I'm going to write X plus 30, but that's the same thing. You just add those two together. Now you got to make sure you put it in parentheses. Okay? That is an equation that'll work. That equation will work. So you get 0.2X plus, what's 0.8 times 30? 24? 24 equals 0.4X plus 12. All right, solve that. Solve that. I'm going to put that down underneath here. 0.2X. 0.2X plus 0.8 times 30 equals 0.4 times X plus 30. Let's see, what is it? I get 12 equals 0.2X, right? And then divide by 0.2, 60. X equals 60 liters at what percent? 20 liters of the 20% solution. Is that what the question asks? All right. Now, I'm not going to have enough time. Maybe we'll hit that. But a lot of times, if you like to have things in a chart or it helps you to organize things, this is a real good way. This will be on the notes. Try to get to it tomorrow. Okay. You just basically just fill in, and then you get your equation. We do that. I do have a few problems for you on page 102. If you get stuck on one, move on, come back. Don't spend like an eternity on one. You know you really like math is when you get stuck on a problem and then you dream about it. Okay, so you ever get to that point, okay, you might have a future in a math teacher. And the answer comes to you.
thought it was the screen. I didn't want to hear it, and I couldn't figure it out.